Okay, let's solve mini quiz 7.4, which is on the graphs of inverse functions. Now, just to recap, the graph of an inverse function looks just like the original, except it's mirrored over a diagonal line. Okay? And because of that, all we need to do to check whether a function is invertible or not is use the horizontal line test. Because a horizontal line will mean that two different inputs have the same output. And if that's the case, then the inverse won't be a function, right? It won't follow the vertical line test. So the horizontal line test checks for invertibility. Now, this is a little small, but if I zoom in here, this graph here would pass the horizontal line test. No matter how I pass a horizontal line through it, it never hits the graph more than once. So this is an invertible function because it passes the horizontal line test. And I'll just call this the HLT for short. Meanwhile, this graph here, I can see that if I passed a horizontal line through it here, I will hit it multiple times, there, and there. So this would fail the horizontal line test. This is not invertible. It fails the HLT. How about this one down here? Let's zoom in again. No matter how I pass a horizontal line through it, it never slices the graph more than once. It passes the horizontal line test. So it is invertible. Finally, this graph, which looks a lot like my 1 over x squared graph, if you remember that from the project. Well, if I pass a horizontal line through it here, I hit the graph more than once. So this would fail my horizontal line test. Okay, so the horizontal line test checks if a function is invertible. The vertical one, the vertical line test, tests if the original is a function. All right, so here is a table for f of x, right? So these are our inputs. I'll just label them that way because I like to remember. Here's our outputs. Okay. And it asks me, which of the following is not a point on f inverse of x? Well, hang on, let's see here. Well, it kind of looks like 6518 isn't on here because like isn't this the input and this the output? Well, wrong, because this is talking about our inverse. Okay. We need to switch inputs and outputs when we're talking about the inverse. So if the inverse, we're talking about the inverse, then these guys are the outputs and these guys are the inputs. So these ones should go first. The ones on the bottom, they need to go first. So if we think about it that way, is 6518 on the graph of the inverse? Yes, it is. There it is. 65, comma 18, because the inputs are on the bottom now. How about negative 594? That looks like it'll be over there. What about 2222? That's on both the original and the inverse. But 5118, well, it looks like that should be this one. But hang on, we're talking about the inverse. Okay. Is 51 the output or the input? For the inverse, 51 is the output because we've switched already. But here it's the input. Ah, that's no good. So this is the one that's missing. D is missing from the graph of the output. All right, let's keep going to the other side. The following is the graph of g of x. Okay, so we have to go to the next page. Here's g of x. And we're asked for the domain and range of g of x. Now, I didn't specify this in some of the classes, so if people made a mistake here, I tried to be as lenient as possible, but actually, the graph of this function actually ends at these points here. It ends there and there. Okay. So the domain is just all of the x values from there to there, all of the x values that that graph covers. Well, what are they? Well, it's labeled for us negative 1.26. And then what's the top one? Well, it looks like it goes all the way up to 2. Those are the x values. Now, do we want to use a solid or a square bracket or a round bracket? Well, this looks like a solid dot to me, so let's use a square bracket because we are including that point on the domain. Same thing up on the top there, that looks like a solid dot to me, so it is also a square bracket. Meanwhile, the range we can see goes from down here from 0 to 10, right? These are all the y values. So 0 to 10, and again, we're using our square brackets. All right. Next, it says using the points given, sketch G inverse of x. Well, like I said earlier, the graph of G inverse of x is going to look just like the graph of G, except all of its points will be mirrored along this diagonal y equals x line, right? So if I turn my head sideways a little bit, I can kind of see where these points are supposed to go. For example, this point here, 0, 2, should go over here to 2, 0. This point over here, negative 1.260, should go to here maybe, right? 0, negative 1.26. Right, how about here? 1 comma 3 will go to 3 comma 1. There we go there. Okay. And over here, 2 comma 10, well, that'll go over to 10 comma 2. So now if I want to graph this, let's see, I'm not much of an artist, but I kind of go like that. Okay, well, not great, but I'll call it there. Oh, wait, I can't move past that X there. So I need to continue along and just get right up to the point, not going past it. Okay, so that's a pretty good sketch. I would mark that fine. Now we're asked for the domain and range of the inverse. So now the domain and range of this thing. Well, I could just read it off the graph. I could just read it off the graph. But if I'm clever, I can remember that, hang on, if I'm switching all of the x's and y's, then logically the domain and range should just switch as well, right? So the domain of G is this, negative 1.6 to 2, which means that the range of this new thing is that. So the domain becomes the range of the inverse. And in turn, the range becomes the domain of the inverse. All right. So the graphs of our inverse functions simply look like their originals, except mirrored like a butterfly over this diagonal line. And it switches all of the x's and y's, the inputs and outputs.